For this, what is Rn? Earlier I have said that find equivalent resistance of some block box. You have to apply some input potential Vt and find the current flowing from the source Vt. R equivalent is nothing but ratio of voltage by current. So what will you do here? Here you will apply some V test. You will find I test. What is I test here?
0.
So R equivalent is nothing but
Infinity.
infinity. Whereas what is R equivalent from here? If you apply some V test, what is the I test flowing?
Minus GMVGS.
minus GM.
What is VGS?
Minus VT.
VG.
So it is nothing but
1 by GM. Oh.
for those who are not able to follow this, I will go into small signal analysis and explain. See, what is the equivalent circuit for Mosfet? Nothing but you have your VGS and current GM VGS, and this is the potential VGS. Okay. For now, what we have done, we have connected gate to ground, drain to ground, source to VT. So I will connect gate to ground, drain to ground, and input to VT, source to VT. Okay, this is source potential, this gate potential, this is drain potential. So what is VGS here? VGS you can write as VG minus VS. Here VG is 0, VS is VT. So VGS is nothing but minus VT. What is the current IT? IT is minus GM VGS because they both are in opposite polarity. So IT is nothing but minus GM into VGS is minus VT. IT is GM VT. From this you will get R equivalent
1 by GM.
R equivalent to be 1 by GM. Is it okay with everyone? Hello?
Yes.
Yeah. What is R equivalent in this case?
VD 1 by GM.
Hello? Anyone?
Infinity.
Here, this is VGS. VGS is 0 implies GM VGS nothing but ID
IT
equals to 0.
0.
So the current flowing from here is 0. and the potential is, let us say, Vt. So R equivalent is Vt by It, Vt by 0, that is infinity. Now we will increase the difficulty of the problem and solve. What is R equivalent seen from this node? How to solve this? So first I will replace the Mosfet with its small signal equivalent.
అదేలే తెలుసు.
Drain to source, there will be a current flowing GMVGS, and drain is connected to
Ground.
gate, drain, source. Drain is connected to ground, gate is connected to ground, and at source you have some resistance
ఇస్తుంది. నేను just
RS. Okay, so here you apply potential Vt. Here the current flowing is It. Now how to find Vt by It? Any idea? What should I do here? KCL, KVL.
KCL.
KCL. KCL.
KCL. First of all, we will determine the relation between VGS and VT. Here also, VGS is VGS
VG
is
minus
minus
V
VT.
minus
Okay, similar to previous problem. This problem here we got VGS as minus VT, right? Since VG is 0, VGS is minus VT. So we'll apply KCL at node VT. Can anyone tell me the KCL?
అది కంటాడు.
VT by RS
VT by RS
VT by
plus
RS
plus
minus
GMVGS.
GMVGS
సారీ, ఈ
minus
ఇలా తీసుకున్నాం కాబట్టి మైనస్ GMVGS
GMVGS
is equals to IT.
is equals to IT.
is equals to IT. Okay. VT by RS. Since VGS is minus VT, this will become GMVT equals to IT.
ఏంటి కామెంట్ ఇస్తే it is equals to 1 by RS GM is equal to 1 by GM parallel to RS.
This, if you simplify, it is equivalent to 1 by GM parallel RS. Hello. Is it okay?
Uh,
Yeah. Now What is the gain V naught by Vi in this case? How to find the gain?
Small signal analysis.
Small signal analysis. See, for that we'll go by one simple funda. We'll solve this first.
Actually, for that one GMRT and the GMRS directly I can tell.
If somehow if we can write VGS in terms of Vi, we can find out the relation.
Yes.
Here Vs is
GM
GM
VGS into
VGS into Rs.
RS.
Okay, the
Hmm.
current flowing here is GM VGS, and this node potential Vs is GM VGS into Rs. We can write
VI
VGS as Vi minus
minus
Vs
VS
into
into RS.
Rs. So if I send Vs terms to one side, it will become 1 plus GM Rs is equals to GM into Vi. Or we can do this. Apply KVL minus Vi plus VGS plus
Minus
GM
1 plus
VGS
GM
Rs is equals to 0. Vi is equals to VGS into 1
is
plus
plus 1
GM
plus
Rs.
GM
VGS is Vi by
divided
1
by
plus
1 plus
GM
GM.
Rs. Okay. Now here, what is V naught by Vi? That is nothing but minus GM VGS
VGS
RT.
RD
I replace uh, VGS with
VGS
Vi by
VI by 1
1
plus
plus
GM
GM
RS
Rs into
minus
RT.
GM RD 1 plus GM RS
V naught by Vi is minus GM RT by 1
1
plus
plus GM RS.
GM Rs.
Yes.
Is it okay? What is happening here is because of Rs, gain is
Decreasing
decreasing. You remember earlier the gain was
minus GM
GMRD
RD.
minus GMRD. Now the gain is minus GMRD by 1 plus GMRS. What is happening is earlier the applied voltage came across VGS. Earlier VGS was VI. Now VGS is VI by
VA
1 plus
by 1 plus
GMRS.
GMRS.
So obviously the gain decreases by a factor of 1 plus GMRS. Is it okay to everyone?
Ashit,
Uh,
the above part, how you did via like small signal analysis, V naught is equal to minus V1 is just all.
yes, yes.
Okay.
So if I connect RD here, this node potential is minus GM VGS into RD, right? This is the current flowing out of
Yeah.
the node GM VGS.
Mm.
So current flowing into the node is minus GM VGS. So it will become minus GM VGS RD.
Okay.
So based on this, I will ask some simple question.
What is the gain? Can anyone tell quickly without small signal analysis? Assume both the GMs are equal.
GMRD.
GMRD.
GMRD. Are you sure? Hello.
Sure, Anna.
Oh,
See, come, I will prove you wrong. See,
actually,
earlier we got the formula, same formula you apply as the above case.
okay.
Minus GMRD by 1 plus GMRS. The
Actually,
difference is
this is GM.
here in case of RS, you have a resistance of, what is the equivalent resistance looking from here?
GM.
Anyone?
GM. I know.
Hello. The
Anna,
equivalent
GM.
resistance is, come
1
on
by
man,
GM.
how can resistance be
Yes.
GM?
Sorry. 1 by GM. Yeah. I got. Understood.
So the gain is minus GMRD
GMRD
by
by
1
1 plus
plus
GMRS.
GM
GMRS.
RS
RS.
minus GMRD by 1 plus GM into 1 by
1
GM.
by
Here
GM.
in place of RS you have 1 by GM. Have replaced RS with 1 by GM. So GM cancels.
This is a minus
That
GMRD, right?
is minus GMRD Lila.
By 2.
Yeah.
By 2.
See, you should not get scared with this kind of problems. You should be ready to solve any kind of problem with a simple intuition from smaller circuits. See, earlier we have solved this. This we have solved. This you should remember that the gain is minus GMRDB on plus GMRS. With this intuition, you should be able to replace this MOSFET as 1 by GM resistance. Then plug the values and you will get the answer. For those who doesn't know the equivalent resistance of this circuit as 1 by GM, I will explain. This is called diode connected MOSFET. R equivalent. Now draw the MOSFET, small signal equivalent is GMVGS. Here you have VT, the current flowing is IT, and the gate is connected to drain. So what is VGS here? VGS is
VT. VT minus
VGS is VT,
GM is
since VG potential is VT, because gate and drain are connected, and source potential is ground, so VGS is VT. So what is the current flowing here? Current flowing in this branch, I
Zero.
is
I is equal to
0.
0.
So
Ground means L equal to 0
IT
ne.
is GM
GM VGS, VGS, I mean
VGS. VGS is
GMVT.
nothing but VT. So VT by IT is 1 by GM, that is R equivalent. Is it okay? We'll move on to look at some other variations. See, we'll look at something called as channel length modulation. You have your channel, right? Let us say this is the channel. If it is drain, it will be source. As VDS increases, this channel length will vary. It will be cut down as this. To characterize this, we will uh, term something as R naught or RDS. This is nothing but output resistance. This is given as 1 by lambda ID.
ID.
For now, you remember it as some output resistance. It brings the dependence on ID VDS. Earlier, ID was some half K VGS minus
Minus
VT whole
V
square.
VDS square.
Now, with channel length modulation,
ID is equal to half KT
this
minus VT whole
new ID
square.
dash will be
VT square
equals
by
to ID into 1 plus lambda
and ID
IDS. This lambda is channel length modulation coefficient.
coefficient.
Lambda is nothing but delta L by L. It is related to how the
From length
uh,
variation.
channel's length will
Variable.
vary.
Variable.
This is I'm not going to
Length
discuss
of the
this.
channel.
If anyone is interested, you can refer textbook or some standard lectures. So now, since we know what is channel length modulation and the output resistance dependence, see, look at here. Here also the small signal resistance depends upon IDS. Earlier I have told that GM, small signal transconductance, depends upon the current ID. Here also the small signal resistance are not depends upon the current IDS, but it is here it is inversely proportional. There GM was proportional to ID. Okay, we'll look at the problems, same problems with channel length modulation. Small signal analysis with the channel length modulation. Before discussing this, we will just draw the Mosfet equivalent with CLM. Gate, drain, source
Are
is
they
equals to
similar or parallel?
the current flowing from drain to source is same, that is GMVGS, but here you will have an additional resistance of RDS from drain to source. This is the only difference between these two models. When they say that lambda is 0, it implies that R naught or RDS is infinity. So need not consider RDS in your calculations. When they say that lambda is not equals to 0, R naught depends upon lambda as 1 by lambda ID. So you have to calculate R naught with the given lambda value and from the quiescent current ID. Is it okay? So now here CLM includes, that means lambda is not equals to 0. What is R equivalent here in the circuit?
Infinity.
Will there
Infinity.
be any current flowing?
Infinity.
Yeah, similar
Infinity.
to the previous problem. Since IT is 0, R equivalent will be infinity. See, if I am going fast, you can tell me when at which point you are not getting it.